Good morning, good afternoon, or even good night. My name is George, and we're going to be going over MCAT material. Um, this is actually, I actually got some of my material from Exam Crackers. I do not own anything from Exam Crackers. I don't, I'm not sponsored by them. And I think it's a very good resource. And if anyone wants to prepare for the MCAT, I think Exam Crackers is definitely a good way to go. So yeah. Anyways, today I'm going to be talking about the MCAT section about the Lewis dot structure, or this is just the lecture about it. And the Lewis dot structure is basically just a structural formula, and it's one of the most basic structural formulas in not just organic chemistry, but every type of chemistry. So, with the Lewis dot structure, there are three types of rules. The first rule is that the first rule is that you have to find all the valence electrons for all the atoms in a molecule. So, first rule, find all electrons, or E. Electrons are usually symbolized with a negative E. For all atoms in a molecule. Now, this is important because uh, an example of this would be where we'd have maybe water, right? So let's draw water. Get my blue. Oh, excuse me. That's fine. Yeah, that's fine. All right, so let's get the blue out, and we're gonna draw blue for oxygen. We're gonna do H2O's Lewis dot structure. Okay. Here's water. Another water. So here's one. Let's draw the electrons in yellow. I like that. That would be a cool color. So yellow, yellow, right? And the valence electrons for oxygen is 1, 2, 3, 4, 5, 6. So, in case you don't know, the number of valence electrons for hydrogen is 1. The valence electrons for oxygen is 6. So there's 6 here, 6 valence, and 2 hydrogens here. So, first rule, find all electrons for all the atoms in a molecule. The second rule about the Lewis dot structure is, and here we go, the second rule is that one pair of electrons are used to create one bond between each atom. So, a pair of electrons are used to form one bond between each atom. Okay, so an example of that is, again, if we look back at the water, right? I did it again. Oh, well, that's okay. What a bummer. I'll learn how to do that later. So another example is the water, right? We're going to use a Docker blue this time. So you have water, right? And we have our hydrogens. And another hydrogen over here. And as you can see, I'll show you in a second what's going to happen. Oh no, let me change that. Let me use that in black. Hello. Hello. Alright. All right. So here we have a pair of electrons, right? We don't have a pair of electrons yet, but we see all the electrons, right? So we followed the first rule, all the electrons for each molecule. Next one is one bond is formed between each atom with pairs of electrons. So here's an electron from the hydrogen, an electron from the oxygen, and they're going to form a pair, and that is how they create a bond. And the same thing here. You see there's an oxygen here. There's oxygen here with one electron, hydrogen with one electron, and they can share because look here. Look here. As you can see, it was originally 6, and if you don't remember from regular chemistry, all atoms want to have a full valence. Hydrogen's the exception with 2, but with oxygen, they have 8. Or, sorry, yeah, they want 8 electrons. So if they're sharing, that means technically this oxygen is, the hydrogens are sharing the electrons with the oxygen, and that is why it will have a full octet, or 8 electrons in its group. Well, we're just about to go into that next rule, which is actually about arranging the atoms to satisfy an octet rule for a duet rule, excuse me, for hydrogen. Oops, I put a 3. Put a 2, I need to put a 3. You know what, maybe I should just use blue because this thing's not very nice. Alright, so we're going to put number 3. And the third rule is electrons remaining around atoms can satisfy either the duet rule for hydrogens and the octet rule for all other atoms. Oops. So what does that mean? Well, if we look back at let's do an example actually. So an example here would be I'm going to draw methanol. If you don't know what methanol is, the structural formula for methanol is CH3OH. Okay? Now, here's what the structure is going to look like. So we have, let's try, oh god, I'm gonna put pink for carbon. So, oops, I gotta stop doing that. So pink for carbon. So here's a carbon. Draw the hydrogens. And let's draw an oxygen because we need that oxygen, right? So here's the 3 hydrogens, right? We have 3 hydrogens here next to the carbon. We have an oxygen next to the carbon. You see that right there? And then we have a hydrogen next to the oxygen. So let's draw another hydrogen. Ta-da! Oop. Okay. Now let's draw our electron pairs. Let's follow all the rules from the beginning. So now let's draw our electrons. So there's 1, 2, 3, 4, 5, 6. And if you don't know about carbons, this is pretty common. You need to know these things. Carbon's valence is 4. Oxygen's valence, let me draw the 4 first. 1, 2, 3, 4. Hydrogen's valence is 1. Okay. And carbon's valence is actually 4. Sorry, I think I already said that. My bad. But the point is that we follow the rule, which is find all the electrons for all atoms in a molecule. So we've done that. So we have 1 here for hydrogen, we have 6 here for oxygen, we have 4 here for carbon, and we have 1 for each hydrogen here. Next thing, a pair of electrons, E minus, are used to form one bond between each atom. So let's see. Here's a pair. Ta-da! Here's a pair. Ta-da! Here's a pair. Ta-da! Here's another pair. Ta-da! And here's the final pair. Now notice how how electrons are still on the oxygen, and that's okay because when oxygen wants to be in its neutral state, it will actually be with four electrons open and two electrons being shared between other atoms. Now this is the methanol, and as you can see, we've made our pairs. Now here's the distinction or the difference between the duet rule and the octet rule. As you can see, the duet rule was formed between the hydrogen and the carbon, but the duet rule used only two electrons, right? Duet, you think of a pair, would be two, right? Okay. Now the next thing we look at also is the octet rule. So octet rule, if you can see here, octet sounds like what? It sounds like the number 4. Oh no, sorry, not 4, it's 8. So the octet rule means that there's going to be 8 electrons. Now let's look. What atoms here actually share the octet rule, meaning that they have a total of 8 electrons either being shared or they have it in total? Well, let's think about it. I'll give you a second to try and think about it, and we'll start right now. Ugh, cold. All right, did you figure it out? There's actually 2 atoms in this methanol structure that actually share the octet rule, or they follow the octet rule. One of them is carbon. As you can see, it has 4 pairs. But a pair consists of how many electrons? 2. So 4 pairs times 2 electrons in each pair means 8 electrons. And that means carbon follows the octet rule. So I'll just draw a nice arrow here. And the other thing that follows the octet rule is, as we discussed earlier, is oxygen. Because why? Let's look. Well, we have 2 electrons here, 2 more electrons here, and that means a total of 4 electrons, kind of exposed to the environment in a way. And then we have 2 pairs. And remember again, how many electrons are in a pair? 2. So that means there are two electrons in each pair, and there's 2 pairs. That means 2 times 2 is 4. That means 4 electrons in all the bonds. And there's 4 electrons that are freely available to the oxygen atom, which means there's a total of 8 electrons. Again, this oxygen follows the octet rule.